Good morning, everyone. Today we'll be discussing about image formation in spherical mirror. Let us see how an image is formed when the reflection of the object is formed on the mirror. That is, we will discuss this image formation with the help of ray diagram. Let us see image formation in spherical mirrors. So, image formation in spherical mirror. For this, we will consider 6 different positions of the object, and for that we will draw the ray diagram and we will see how the image is formed and where the image will be formed. That is nature of the image and characteristics of the image that is formed. Let us see first one, position of object. Positioning of object. Second one is ray diagram. Ray diagram and position of image. Next one, nature or characteristics of image. Nature of image. So we will see the characteristics of image that are formed with the help of spherical mirrors when the position of the object is changing. That is, let us see the first position of the object. First one is at infinite distance. When we keep an object at infinite distance, at infinity. So when the object is at infinite distance, how the image will be formed? Let us see. Consider a concave mirror. Let this be pole, center of curvature and principal focus, and the line joining these points is principal axis. So we are considering that the object is at infinite distance and the rays that are passing parallel to principal axis, when they fall on concave mirror, after reflection they passes through principal focus. So this is incident ray. So when the rays are incident parallelly on the mirror, then after reflection they passes through principal focus. So this is incident ray and this is reflected ray, and the reflected ray is passing through principal focus. And we will, for representation of image, at least we need 2 incident rays. Let us see the second ray that is also coming from infinite distance. When it falls on the concave mirror, after reflection it passes through principal focus. So these reflected rays are intersecting at a point F. That F is principal focus. So this intersection point gives us image. So that is the image, the position of the image now is at F. Position of image is at F. Now nature of image. What is the nature of the image that is formed? So the image that is formed is highly diminished. That is means less in size or point sized image. Let us see. Highly diminished or point sized image. Whether the image that is formed is real or virtual image, as the reflected rays are intersecting here, so the image that is formed is a real image. So highly diminished point sized image, real, highly diminished and point sized image is formed at F. So for the position of the object at infinite distance, then this will be the ray diagram and the position of the image is at F, and the characteristics are the image that is formed is real image and that is highly diminished or point sized image. Now coming to second one, when the object is at a distance, which is between center of curvature and infinite distance. So then second one, beyond C. That is beyond center of curvature but not at infinite distance. So the object position is between infinity and center of curvature C. Let us see the position of the image and nature of the image. So this is concave mirror, pole, center of curvature, principal focus. Now we are considering an object of certain size which is between infinite distance and center of curvature. Now consider a parallel ray that is passing from this. So the incident ray is passing parallel to principal axis. After reflection, it passes through principal focus. Now consider another ray which is passing through F, that is principal focus. So for this, as the ray is passing through principal focus F, the reflected ray will be parallel to principal axis according to rule 2. So these two are intersecting at certain point, and this point gives us image, and this will be the size of the image. So this is the size of the image, and this is the size of the object. Now the image that is formed is diminished image. So this is the size of the object, and this is the size of the image. So image that is formed is less in size. So we call that as diminished image, and the position of the image between C and F. So position of image is between C and F. So between C and F. The nature of image. So whether it is real image or virtual image, as the reflected rays are intersecting, so we call that as real image. So real, whether it is inverted or erected image, as the image is below the principal axis, we call that as inverted image. So real, inverted and diminished image. And diminished image is formed between C and F. So for the position of the object, if the position of the object is beyond C, this will be the ray diagram, and position of the image is between C and F, and the nature of the image is real, inverted and diminished. Now let's move to third position, that is at C. When the position of the object is at C, let us see the characteristics of image. Now third one, when the object is at center of curvature C. So at C, let's see the ray diagram. Concave mirror, pole, center of curvature, principal focus. Now we are considering the object is at center of curvature. So this is the center of curvature. So this is the height of the object. Consider a ray that is parallel to principal axis is falling on the mirror. So after reflection, it passes through principal focus. And the second ray which we will consider is the ray is passing through principal focus. So when the ray is passing through principal focus, after reflection, it passes parallel to principal axis. So these two rays, reflected rays, are intersecting at certain point, and that intersection point gives us image. So this will be the height of the image or size of the image. So if we draw that properly, we can say that the size of the object is equal to the size of the image, and the position of the image is same as that of object, that is at C. So position of the image is at C. So because these two are intersecting at a point exactly below C. Now nature of the image, as the reflected rays are intersecting, the image that is formed is real image, and the size of the object, if you consider the size of the object, size of the image is equal to size of the object. So size of the image is equal to size of the object. So real, and whether it is inverted or erected image, as the image is forming below the principal axis, the image that is formed is inverted. So real, inverted and same size image is formed. Same size image is formed at C. So these are the characteristics for the position at C. Now let us see when the position of the object is between C and F. If it moves further to a position such that it is between C and F, let us see the characteristics of image that is formed. So fourth one is when the object is between C and F. So 4, position of the object is between C and F. Consider a concave mirror, and this is pole, center of curvature, principal focus, and principal axis. We are considering the position of the object as between C and F, and let this be the size of the object. Consider a ray that is passing parallel to principal axis. After reflection, it passes through principal focus. So this is reflected ray. Now we will consider another ray that is passing through principal focus. So when the ray is passing through principal focus, after reflection, it passes parallel to principal axis. So the reflected rays are intersecting at a point such that the image is formed beyond C. So this is the size of the image, and this is the position of the image. So position of the image is beyond C. That means it is moving. It is this side of C, and the size of the image is greater than the size of the object. So the image that is formed is real, inverted, and enlarged image. Real, inverted, and enlarged image. Why we are saying that as enlarged means the image that is formed is greater in size when compared to the object. So enlarged. You can say enlarged or magnified image. Enlarged or magnified image is formed, and the position of the image is beyond C. Beyond C. So when the position of the object is between C and F, this will be the ray diagram, and the position of the image is beyond C, and the nature of the image is real, inverted, and enlarged image. Next one, fifth position. Let us see the position of image when the object is at F. So position of the object is at F. Let us see the ray diagram. And this is pole, this is center of curvature, and this is principal focus. And when the object is at F, that is principal focus, consider a ray parallel to principal axis. When the ray is passing parallel to principal axis, after reflection it passes through focal point or principal focus. And this will be the reflected ray. And the next second ray we will consider that as it is making certain angle with the principal axis. After reflection, so second ray which we consider is, let the ray is passing through center of curvature. When the ray is passing through center of curvature, that means it is passing or it is incident normally on the mirror. When it is incident normally on the mirror, reflected ray will come back in the same path. So when we extend these back, so this will be the reflected ray, and these two rays might intersect at infinite distance. So the position of the image is at infinite distance, and the nature of the image that is formed is real and the inverted, as the image that will be formed is below the principal axis, that is inverted image. And let us see the size of the image, highly magnified. We will get that as highly magnified image at infinite distance. So highly enlarged or highly magnified. Highly enlarged image. So real, inverted, and highly enlarged image will be formed at infinite distance for the position of the object at F. Now the last one is, sorry, this is fifth one. Next, last one, that is sixth. When the object is between F and C, that is pole and principal focus, let us see the characteristics of image or position of the image. Now consider a concave mirror. And this is pole, center of curvature, principal focus. So between F and P, that is principal focus and pole. So let this be the size of the object. Consider a parallel ray, and after reflection the ray passes through principal focus. And consider another ray such that it is making certain angle with the principal focus, and after reflection it passes with the same angle, and these two rays appears to be diverging. So we will extend these rays such that these two rays intersect at certain point. So extensions of these reflected rays intersect at one point behind the mirror. So this will be the position of the image. So here, when compared to other ray diagrams, here in this diagram we are seeing the intersection of extensions of reflected rays. So as the extensions of reflected rays are intersecting, we call this image as virtual image. So let us see the position of the image. So position of the image is behind the mirror. Behind the mirror. Now if you see the characteristics, as reflections of, extensions of reflected rays are intersecting, the image that is formed is virtual. So virtual, and whether it is inverted or erected image, as the image that is formed is above the principal axis, we call that as erected image. So virtual, erect, and now let us see the size of the image. As we are considering an image of size, certain size, we are getting an image, this is the size of the object, and this is the size of the image. So size of the image is greater than the size of the object. So the image that is formed is enlarged image. So enlarged image. So for the position of an object between F and P, this will be the ray diagram, and the position of the image is behind the mirror, and the characteristics of image are virtual, erected, and enlarged image will be formed. So these are the ray diagrams. So for different positions of the object. So we have seen the image formation in spherical mirrors with the help of ray diagrams. Now we will see about the image, how image will be formed if the mirror, spherical mirror that is formed is a convex mirror. So in these cases, for these 6 positions, we are considering only concave mirror. So the image formation in spherical mirrors, that is concave. We explained about image formation in concave mirrors. Now the next topic is how image will be formed when the mirror that we are using is convex mirror.